In this video, we are going to do problem number 23, collapse. Alright, so I already have it downloaded and opened up in DrRacket, so let's just look for the problem statement here. Problem A, some nums and multnums are provided to you above, right? So these two are there. Abstract from them a new function, collapse. Hint, it has three arguments, a function, value, and a list. Alright, so pause the video and try to do A on your own. Try to abstract multnums and some nums into a new function called collapse. Alright? So I'm gonna go for spoilers in 3, 2, and 1. Alright, I'm assuming that you guys took a good swing at it, so now let's go over it together. So looking at these two functions, what's similar about them? Some nums and multnums. Well, let's look at the signature. They both consume a list of numbers and produce one number, right? Same with multnums, right? Consumes a list of numbers, produces one number, right? So some nums sums up all the numbers in the given list. 2 plus 4 is 6, and then this one multiplies them. 2 times 4 is 8, right? So since they consume a list of numbers, they still have the same general recursive template structure where they do something when the list is empty, hitting that base case eventually, and same with this one where the base case is 1, all right? And what else is different about them? Well, the operation here, this one's a plus and this one's a multiplication, right? So why are the base case different? Well, because if this were 0, right, anything times 0, right, 2 times 4 times 0, it will eventually hit this base case and it's going to be 0, right? So yeah, 0. So it has to be 1. And why is this not 1? Well, because 2 plus 4 plus 1 is going to be 7, right? We're not going to get that 6 there, right? So let me undo that like so. All right. So that's why they're different. Anyways, let's try to abstract one of them. Then copy and paste the other one. We established that they're similar. And I'm going to rename it to collapse. And they give us a hint here. It has three arguments, a function. So there we go. A value. So let's call it V. And then a list. And the list is already from here, right? So let's just abstract these things away. So V will most likely go there. And this is going to be the function, right? So we can abstract, instead of hard coding multiplication and plus here, we say that someone has to pass in that function, like so. I'm going to hit Control-I to reindent. Also rename this to collapse, the recursive call to collapse, and make sure it passes these two values in. All right. So since this V, we can give it a better name, right? What it really is the base case. All right. So that looks like a good enough abstraction. Let's actually make sure that it is an abstraction by writing some tests. So check expect collapse. So we're going to grab the plus function from some nums, right? We're just grabbing the structure here. Base, so the base case is 0. And then let's grab these two list of numbers, 2 and 4. All right. All right, so is that the same as this? Right? Is calling collapse with plus 0 list 2, 4 the same as just calling the some num function with the list 2, 4? So let's just run this test. It looks like it does pass that test. All right. So make sure it's the same for multiple nums as well. So check expect collapse. I'm going to grab this multiplication here. It's going to be 1 for the base case and then list 2, 4. Right. So do these both produce the same number 8? Right. Hit Control-I to reindent here. All right, there we go. And it looks like it does. I'm going to space these out. So now we have established collapse is an abstraction of multnums and some nums. And that is problem A done. All right, so now let's move on to problem B. Problem B says use the abstracted function collapse in problem A, so that's what we did just now, to reimplement some nums and multnums, all right? So, try to pause the video and do that on your own. I'm gonna go over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So, some nums, right? We established that they're the same, so we can just replace all of some nums. Like so, with a call to collapse, where the function is plus, the base case is 0, and then we pass it the list. All right, so let's just run it, make sure the test still pass, like they do. Let's eat out the same for the cond here in multnums. We know that we can just rewrite it as collapse. This collapse abstraction with the function being multiplication, base case 1, and then passing in the list itself. And we see that all 6 tests still pass. So that is problem B done. All right. So now let's move on to problem C. So it's highly recommended that you do this. You copy collapse, right? So this collapse abstraction, and re-implement all 13.0 problems with collapse. All right. So I recommend you go to the website and download these solution files for 13.0, or maybe you've done them in the past and you already have them, right? And re-implement them using collapse. So I'm gonna do one of them for you guys. All right, so solutions, and then 13.0, I'm gonna do letter count, all right? And I'm gonna rewrite collapse. Can copy and paste this here and paste it down here. And I'm gonna paste it right over here. All right, so try to pause the video and try to use collapse to re-implement letter count for 13.01, all right? So I'm gonna go for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it, so now let's go over it together. So looking at the collapse abstraction and the function that we want to write in terms of this abstraction, collapse, right? Let's look at the similarities. They both have a recursive structure. They both have a base case here. In this case, it's 0. In this case, it's the variable base that someone will pass in, right? And this is, they do something else when the list is not empty. This adds the string length of the strings in the list, right? So moo is 3 characters, wolf is 4 characters, and 4 plus 3 is 7. So that's this test here, right? Barn, right over here. Letter count of barn is 7. All right, so let's actually focus on what we know, right? We're trying to define a letter count. Let's call it letter count v2, right? That has the same signature here, right? But uses collapse as the abstraction to implement it. All right, so let's actually fill in these parameters, right? Let's fill in what we do know and then work from there, right? So collapse takes in a list. So that's just the string list. All right, what does it take for this argument? The second argument here, the base case. What is the base case for a letter count? Well, it's 0, right? That's what we want the base case to be. So let's plug in that. All right, now comes the hardest part, right? This plus, if we write a plus here, right, it's not going to work out that well because we can't add, strings, right? These are going to be strings. We want to also do a string length operation on them. So let's actually copy and paste this test and let's see that error actually. String count v2 in action. And let's see, I had to change the language level. Forgot to do that. So you can't have functions as parameters in BSL, but you can do it in ISL. Hashlang ISL plus. All right. So hopefully you guys change the language in this file. Gonna hit Control R to run now. And we get this error here, right? So check expect, letter count plus expects a number given wolf, right? So this can't be a plus, right? So what can this be? Well, it has to be a function that consumes 2 arguments, right? This function, right? We're pretending was plus here, and plus consumes, any number of arguments, but we need a function that consumes 2 arguments, where this is going to be the string, and then this is going to be the recursive call that it will eventually hit the base case, right? So we want to do something to this, which is going to be string append. But we can't do it with just this plus, so it looks like we're going to have to define a custom function. And let's just pretend that it exists, right? We're going to pretend that there's a function that converts the strings into numbers, right? The letter counts, and then adds them up, right? So we're going to call it letter add, right? And let's just define that. Define letter add. All right, so what do we know about this function letter add that we're trying to pass into the collapse function? Well, it's going to be substituted here, right? Letter add is going to be stuck here. And we see that it has 2 arguments, right? If we do that, it has this and this, right? This is going to be the string, and then this is going to be a recursive call to eventually hitting the base case, right? So you can just replace this whole thing with base if that helps you, right? So let's just Control Z do this, and then let's just go back down here. So we know that's a 2 argument function, so this has to take 2 arguments. We'll call it A1 and A2. We know that A1 is going to be the string, right? Because the first of the list is going to be the string, right? So this one is going to be here. We're passing a list of strings. So we're going to get the string out from there. So we know that this is going to be a string then. So let's call it str. And then this argument is going to be the base case, right? So let's just call it base, right? And eventually it's going to be the base case. All right, so actually deducing this function now. All right, so looking at this, right, this is what we want to abstract into this function here. So it looks like we want to turn this into a string length here. So this is going to be that, right? This whole thing is going to be first a string list, right? So we can just write the string length and then the string, right? We don't have to write the first here, right? This can assume a string because we just deduced it, right? And then we want to add that to the base, right? Because there's an add here. And then this is eventually going to be the recursive call that resolves to the base case. So we know that the base case is something that's going to be a number, right? Because this is a number. We're passing a number to the base case for collapse here. So we just do an add here. All right. And let's just run it. And it looks like we get some differs here. So let's just see what's wrong. Oh, I added 0. I meant to add the base case. My bad. I was too busy staring at this. Like there. All right. And it does look like it does work. And this is a little magical. I recommend you use the stepper and step through letter add and letter count and see what the difference is on a mechanical level. But you see that they do behave the same, right? Letter count v2 of barn, right? This list, moo and wolf, 1, 2, 3, 4, 5, 6, 7, right? Produces 7. They both produce 7. They both have the exact same behavior, right? So that is how you abstract letter count with collapse here, right? So I recommend you submit these problems into Handon and check your score and really do all the 13.0 problems with collapse because it really gets some practice, right? Because this was hard to do this enough, right? But anywho, that is about it for this video, and I will catch you in the next one.